Okay, we are Team Robotwars.
Hi.
We're Pete,
Hello.
Suze. Unfortunately, Tiago can't be here today, and then myself, Robert. So what have we been doing? We've been building a bot to make intelligent decisions to play a logical game against other bots. This game is the game of life and death, the one you see on the screen right now. It's based on Conway's Game of Life, but a two-player version. So we play it on a website called Riddles.io. We upload our bot onto the site, and it competes against others that other people have made. So, how does it work? Between each turn, cells on the board can live, they can die either of loneliness or overpopulation, or dead cells in birth. And there's three rules to this game. The first is robot versus robot. So the machine decides which move to make. Second, it's turn-based, and you get to choose one option of a kill, birth, or pass, and it's the last robot surviving. So we wanted this week, or the last 2 weeks, to do a real technical challenge. So we wanted to do two main things. The first, we didn't want to use any external libraries. We wanted to do all the logic ourselves. And the second, we wanted to build our own robot from scratch, as the site has lots of starter bots in other languages. So we went for Ruby, our spec for testing. Firstly, because it's the technology we know the most, or the language we know the most, and the most experienced in, and there was no starter bot in Ruby on the website. And this meant we had some experimenting to do. We had to do some technical challenges. And so we had to do this and just try it out. But then we went back, we scrapped the code, and we approached it from a test-driven perspective with our spec. To the point where now our basic bot, using random moves, is actually accepted by the website and is the Ruby starter bot.
So you've just heard from Rob about how the game works, and now I'm going to tell you a little bit about how our bot works. And so the first element to this is strategy. What's a good way to play the game? And so in the game, there are some patterns that will emerge on the board that are essentially self-sustaining because they've become surrounded by the right number of cells. They will just continue indefinitely. These are some of the patterns on the board just now. And we wrote kill algorithms and birth algorithms that would identify either these patterns on the board belonging to our opponent and kill one of the cells and then let the rest of the pattern wither and die, or identify emerging patterns in our colony of cells that would then seek to help to build them up more quickly and allow us to develop these strong positions on the board. Another element of our bot is efficiency, and so every turn we only had 1,000 milliseconds to decide what move to make and then make that move, which meant there was a limit to the amount of computations to do, and we had to make various trade-offs to do that. One of the things that we did to cut down on the amount of calculation and computation that our bot had to do on any given turn is to make sure that we weren't searching through the entire board every turn, but actually only a section of it, because there were some sections of the board that are highlighted here, where, due to the constraints of the size of the board, those patterns actually couldn't emerge. And the final element of that is actually deciding what to do. How do we make an intelligent decision about what the best move to play is? And so on every turn, our bot will take a sample of different kill moves, a sample of different birth moves, and the pass move, and it will calculate what the board will look like after each of those moves. After it's calculated that, it will look at the net difference in cells between our colony of cells and the opponent's colony of cells, and choose the one that has the greatest net benefit to our bot. Over to Suze now for the challenges we faced.
Thank you, Pete. So we chose this because it was technically challenging, so obviously there were a bunch of challenges, but I picked out two. The first one because it's surprising, I think. You think that writing the logic and the gameplay would be a really difficult thing, but one of the things we had loads of trouble with was actually just linking the basic bot to the website. Where we had to figure out that there was a peculiarity in how Ruby as a language dealt with input-output. It was queuing up all of our requests and then dumping them when it felt like it. And in order to play a game online, you have to maintain a constant input-output flow. You send messages to the website, it sends messages back to you. So that was a little bit of a challenge that we got over. And the second one was really interesting to me, that we were optimizing for a different type of performance. So instead of thinking about good code being very object-orientated, being very sort of apportioned out in terms of responsibility, we had to think, what is going to be quick? What is going to use up the least time? What is going to use up the least computation? And that became not just a technical challenge, but a challenge in terms of rewiring your own brain to think about what is good code in a slightly different way. So that was fun. We had teamwork successes. We had really good balance between independence and communication. Everybody was aware of what features other people were implementing while focusing on implementing their own. So we had very little overlap where people spent 2 days building the same thing and then half of it has to be scrapped. I think because we have that communication, we could accommodate quite different personality types and working styles. People could work together or they could work alone, and that worked really well. And because of that, we had a focused but relaxed atmosphere, which, I don't know, I had a lot of fun, and I think everyone else had a lot of fun as well. So without further ado, here is Francine, who is our bot. Here is a pre-recorded demo where she is playing someone called Coding Whalebot, where she is going to win, eventually, if this keeps going. This is a little bit out of date. This is from yesterday when we were ranked 28th on this competition. We are now, as of when I checked in the pub earlier, at number 22.